GE's perspective on the big engines and look at the technology that we're putting into our engines going forward into the next 10 years or so. I'll start by just looking at our market and looking at some of the challenges that we have as a business. You see that passenger demand and load factors are pretty stable from year over year from 2020 to 2013. Jet fuel is a little bit going down, but when you look at the production volume over the next 7 to 10 years, from 2013 of 2,600 engines up to 3,300 engines in 2020, that's a 4% CAGR rate that we see over the next 7 years. That's something that we're going to have to deal with from a supply chain to be sure that we get things correct and can work through that. As far as the in-service fleet, we're also growing at about 4% CAGR from 33,000 engines in service today up to 46,000. So when you look at what are you going to do in the next with the next engines that are coming in play, GE started a GE9X back in 1989 working on that engine, and it went into service in 1995. And if you look at the new engines that are going to service in the big engine side, it's really a heritage of that architecture that we started in 1995 with the GE9X in service in 2011, and the Leeham engine that will be going in service on our narrow-body engines on the A320neo as well as the 737 MAX. That's got a GE90 type architecture, as well as the GE9X, which we're extremely proud and honored to be a partner with Boeing on that product. I want to talk about those products as we go forward today. What's our model? What do we do to innovate? Well, we want to partner with our airlines and our customers to understand what are their needs. And it starts with fuel efficiency, reliability, cost of ownership, and meeting the regulatory environments with emissions and noise. But how do we do that? We have technology centers all over the world, global research centers where we work on developing the right technology roadmaps. We try to figure out what is the right maturation of that technology. And that is what really differentiates our products, we feel, going forward, is getting our customer needs, having these research centers across the world that we can really partner with to determine what's going to deliver the differentiated technology to our customers to help them succeed in the next decade. So where have we been with the CF6 engine on the wide-body engines, and where are we going with the GE9X? We're very, very honored to have been with the CF6 for this many years. It's over 40 years in service now. It's been a great engine on the twin-aisle market. We have over 24 aircraft that are in service today. But going forward, the GE9X is something that's been envisioned since 2001, 2002, and we got selected by Boeing to power on the 787 in April of 2004. Today, we are sitting with about 400 engines in service, growing that to 2,000 engines in service by 2020. We've been selected with customers to power over 60% of the 787s that have been ordered today. It's the fastest selling wide-body engine that we've ever built, and we certified that engine up to 78,000 pounds of thrust. So how are we doing today? Operators, we've got about 17 operators on the 747-8, 9 airlines and some VIPs, as well as 11 operators on the 1B on the 787. Over 450 engines in service today. We've accumulated about 1.5 million hours between the 1B and the 2B, and almost 270,000 cycles. If you look at the performance improvement plans that I'm sure all of you guys know about, that we've worked on since we entered into service in 2011, or actually when we started working this, we entered in with our PIP-1 product back in 2012. We were projected to have a 1.4% fuel burn improvement. We actually delivered 1.7%. For our PIP-2 engine that's going to be in service later this year, we were projecting 1.2%, we were delivering 1.2%, and then on the 747-8 engine, the 2B, we were predicting 1.6%, and we're scheduled to deliver 1.8%. So execution is a big theme at GE, and it's something that we're committed to, and we're trying to demonstrate our execution and being able to satisfy and make the commitments that we make to our customers. So that was sort of the middle of the market region, if you will, between 200 and 300 passenger airplanes. And if you look beyond 300 passenger airplanes and what we've done and our success in business with Boeing, with the 777-300ER, the GE9X-115B has been a phenomenal engine. We've got over 1,600 engines in service. I've been fortunate enough to be a part of that program since 2004, and I saw the 500th engine produced in 2006, and it took 11 years for us to get to 500 engines. And then in 2009, we got 1,000 engines. We're going to be now in 2013, we're over 1,500 engines. So GE has been committed to delivering technology in the 115D. We've stayed with that, and it's paid off in droves. And from our customers' perspective, we've got 60 customers that have selected that engine, and we really feel like it's paved the way for us to deliver a really great engine in the GE9X that's going to be powering the 777X. So going forward, looking at a 2020 EIS of the 777X family, we're bringing an engine of the GE9X that's going to be 10% better in fuel burn. We're looking at a potential of 3,000 aircrafts in this market. Not saying that we would get all those airplanes, but that's the opportunity that we're looking at. We personally feel that this is going to be an engine that's 5% better in SSC than any engine in service in 2020 with the technologies that we've got going into that. I'll show a little bit about that here in a second. But to deliver those technologies and to be sure that you're staying up to speed on where you need to be with each engine development that happens, you have to continually to develop your technology. You have to mature that technology maturation. We started studying composite fan blades well before it went into service in the GE90 back in 1995. We started this as in technology demonstrator programs in 1986. We entered into service in 95 with a wide chord technology fan blade that was a composite fan blade at 22 fan blades. We continually make innovations in technology steps to improve that going forward. So in 2004, we took that wide chord fan blade, we swept that fan blade and put it into the 115B. 2011, we reduced the fan blades from 22 fan blades down to 18 fan blades in the GE9X. We're making a further improvement with new composite materials as well as reduction in fan blades from 18 to 16 fan blades that will be in the GE9X. So in 2020, when we enter into service with the GE9X engine, we're going to have over 100 million hours that have been completed with composite fan blade technology. We've extended that composite fan blades to the case and never have stopped innovating and developing and delivering this new technology going forward. Something a little bit different that we're doing on the GE9X program that we haven't done on the other programs. We always have a maturation program, but this is the most extensive maturation program that we've ever developed. We're spending more money maturing this technology before we go into a new product introduction. So the top part of this chart looks at some of the technology that we put in. We started a compressor rig test, our 27-to-1 compressor pressure ratio rig test this in 2013. We also started a UPS, or Universal Propulsion System fan rig, in 2013 to look at maturing that composite technology in the fan even further. We go into a ceramic matrix composite demonstration engine in 2014, a full-blown demonstration. I'll talk more about that here in a second. All before we go into our Core 1 test in 2015. This is all a part of the technology maturation to be sure that we get the technology right. And we're maturing this in each component and building many facilities so that we test the technology in the components as opposed to in a new product introduction or in the engine when it comes into service. The final bit starts about our final, or the bottom talks about our final design, and then our first engine test scheduled in 2016, followed by flight testing in 2017, with a certification of the engine in 2018.